Alright, I'm actually going to go ahead and take a screenshot of these steps here and make sure they're ready to go on the next page. I think it'll actually help to have these right in front of me, which is a good strategy for you to realize. Have the steps right in front of you as you're attempting to do some problems here. So what we're going to do, we're going to learn how to algebraically, without having to make a graph, solve a system of equations. So remember, we're looking for an x and a y, all right? So this method that we're going to learn about is called substitution. So it's important that you know the name of the method, because at the end we're going to ask you to solve based on different types of methods, and you need to know the name. So substitution. So think about what it means to substitute. Think about a substitute teacher. It means you have one teacher removed and you put another one in their place. So that's exactly what we're going to be doing. And then we're also going to look at, in solving algebraically, what does that look like for infinitely many or no solutions, just like we did with the graphing video. So substitution method for solving a system of equations, step 1 is to isolate the variable in one equation if it's not already done. So think about the word isolate. Isolate, if I'm going into isolation as a person, if I'm isolated, I'm by myself, okay? So you're going to get one of the variables alone if it's not already done. So when I look down here, I see several spots where there's a variable already isolated. So for example, on this one, x already equals 7. This one, x equals 2y. We have an x isolated in one of the equations in both of these systems. In this system, 2x plus y equals 5. Neither variable is isolated because on this one, the x and the y are on the same side, and on this one, the x and the y are on the same side. Here, I have a y isolated, and then here, I have a y isolated in both equations. So, step 1 is just making sure that that is there. And if that's not already there, you're going to have to figure out how to do that. And so you'll need some support from your teacher when you get to an example where that is the case. And these ones we're doing in the video, they're all already done for you. Our next step after that is to substitute what the isolated variable equals into the other equation. So what that basically is saying is, whatever the isolated variable stands for, you want to put that into the other equation. So if x is equal to 7, then that means I can substitute an x for a 7. So in this equation, I'm going to substitute the 7 in place of the x. So I rewrote that second equation and I substituted the x for a 7 in this equation. That way, all I have left is one variable. I have a y. So 2 times 7 is 14. 14 plus y equals 5. So I'm actually moving on here to the next step. So let me just highlight here. Here is where I substituted what the isolated variable equals into the other equation. My next step is to solve for the only variable that is left. So I'm going to try to solve down for y. So I have 14 plus y equal to 5. It's pretty easy to solve this equation for y. All I need to do is subtract 14 so that the y is alone. 5 minus 14 is negative 9. So I have my equation there. And then take the solution from step 3 and substitute it back. Okay, so we're not actually going to do this one because in this particular example, I don't need to do any work to go back and find x. I actually already know the value of x. The value of x is already given to me, 7. So my final solution for this system is 7, negative 9. I already knew one of the variables, and I found the other one. So I only really had to do 3 steps on this first example. On this one, I have x equal to 2y. So I can already see I'm going to have to do a little bit more work to actually find the x at the end. So in this case, x is equal to 2y. So in my first equation, I'm going to substitute the x for a 2y. So I'm going to put the 2y in place of the x in this first equation. 2 times 2y is 4y plus 8y equals 1. So I need to solve for the y in this case. Notice I met my goal. I have only one variable left. That's what I want to do. because it's easy to solve for one variable at a time. That's what we did all the way back in the first unit. So I have 12y equals 1, which means y equals, and let me just divide this, 1 divided by 12. Is that going to be a nice decimal? No. So actually what I'm going to do is I'm going to leave this as a fraction. 1 over 12. Divide by 12. That's 1/12. So y equals the fraction 1/12. And then now I'm going to go finish my steps here. So my next step is to take the solution from step 3 and substitute it back into the original. So what I'm going to do is I'm going to take this solution for y and I'm going to put it back in the y in the original equation. X is equal to 2y. So to find my x, I'm going to do 2 times the y, which is 1/12. So x equals 2/12, or x equals 1/6 simplified. So my final solution for this one, now that I've gotten my x, is 1/6 and 1/12. Notice how I'm always writing my answers out nice and clear as a coordinate point so I know which one's x, which one's y, and I circle my answer so that I can find it. All right, let's try a couple more examples here. Make sure you're following along with me. I know this can get tedious, but it's nice to see several examples when you're trying something new like this. So y equals 5 minus x. So I'm going to put this 5 minus x in place of y. So where y is in the other equation is by the 3. So I'm going to substitute 5 minus x for the space where y is. Now I'm going to solve this equation down for x. So I'll do the distributive property first. Then I'll combine like terms. 4x minus 3x is 1x. And then I'll subtract 15 to get my final answer, which is that x equals negative 14. I'm just going to move my work up here so that I have a little bit more room. All right, and then I'm going to go back into my original equation that I substituted for. Y is equal to 5 minus x, so that means I get y by doing 5 minus negative 14, which is the same as just 5 plus 14. Of course, if you're feeling really unsure about negatives, you would just type that into your calculator rather than guessing that that's what it is. And so then you'll get 19, that's your y. So my final solution is negative 14, 19. All right, one more. Y equals 1.5x. So I'm going to take that and I'm going to put it in place of the y. So in this case, I'm going to have an x on this side and an x on this side. So I'm going to add 2.5x. So I'll get 4x equals 12, which means x equals 3. There's my x. Now I'm going to go back to my original equation for y. Y equals 1.5 times x. And I will get my equation here, which means y equals 1.5 times 3 is 4.5. So my final solution, 3 and 4.5. All right. Okay, sometimes we're going to have our special cases, so we need to go through these. This is when we have infinitely many or no solutions. So let's look at this first one here. So I'm going to substitute my 3x minus 7 in place of y. So what I did was I know that y equals 3x plus minus 7, so I put it in the space of the y. And then I'm going to change this to a negative 4 here and multiply. Distributive property with that negative 4 there. And then 12x minus 12x, that's going to get me 28 equals 0, or equals 10. And that's not true. 28 does not equal 10. So when you get a statement like that, that's not true, where you don't have any x's left, and that side is not equivalent to that side, that is when you're going to come up with no solutions. There's absolutely no x and y that are going to make both of those true. So in other words, those two lines are probably parallel if I were to graph them. And then this one over here, we're going to have actually the exact opposite thing happen. So I'm going to substitute 4y plus 3 in for x. 8y minus 8y, that's going to get me 6 equals 6, which is true. 6 does always equal 6. There's no more y's though, so I can't get a specific solution. What this means is that there's infinitely many solutions. So all x's and y's that work for the first one work for the second one. That doesn't mean that you can put any number in for x and y and it's going to work. What it means is if you have an x and a y that make the first one true, that same x and y will always make the second one true. So there's infinitely many pairs that make both of those true. So in other words, when you graph those, they'll be the same. All right, now we're getting to the point where you're going to try one. So pause the video, try this one out, press play when you're ready. There's my solutions. You can see all my work there. Go ahead and look over that, and if you have any questions, make sure you ask your teacher and then grab the independent practice sheet to get started.